So what we want to cover is some of the best practices if you're working as a research assistant on a team or on a project. And one of the big tips we can give you is to work in a project folder. That project folder should be under the PI, the primary investigator, underneath of their home directory, possibly the faculty member's home directory. And that directory should be owned by the group. And we can do that with the suid bit on the dir, so that new files created in that directory will be readable and writable by all members of the group. So we can do some things on the back end to make that happen. We will also create symlinks underneath all of the team members' home directories, so everybody has a shortcut to that directory with all the code, with all the data, with all the files that are relevant to that project. So this is like the biggest tip we can give you, is make a dedicated directory that the team works in, and then possibly create subdirectories directory for code and a separate subdirectory for logs or scripts. Or maybe different stages of your pipeline or different programs you're working with.
Actually, Gavin, sorry, we lost you for about maybe 30 seconds, so if you might want to repeat.
Oh, all right. Interesting. The biggest tip we can give you is work within that project directory and create subdirectories underneath of that directory for your raw data and files, for your massage data, maybe separate data by year, a directory for your code, directory for your logs, maybe one for your scripts, or maybe you want to have different directories for your different steps of your pipeline, or your different toolkits or programming languages you're working on. If you need a project directory set up for you, we can do that. So just ask. We can help you do that. It's a little tricky, but we can set it up. So let's say you're an RA and you're working in the department, and you've got two projects with two different faculty members. And let's say that you've got project A with Janet's sales optimization and project B with Daniel's filing analysis. So these are obviously in different directories. Directories are the same as folders. I use folders and directories interchangeably, just so you know. And one of the big things that you need to do is that when you're running code on the HPCC, you have to make sure you're using the correct project. And usually that project is identified by department _ faculty members username _ team. So if you're running jobs and code for the sales optimization, make sure you use Janet's project. If you're running code for Daniel's filing analysis, make sure you use Daniel's project. And do not, I repeat, do not double dip. Do not, if the queue is busy or you've reached the max number of jobs for the project, do not use the other project. This is a big no-no, and we'll shut down everything if that happens. So we spend a lot of, and if you try to game this, the queue subs, or try to do them, we've spent a lot of time massaging the scheduler for the jobs to make sure that everybody gets a fair share and that everything's super optimal and that jobs get completed as efficiently and as optimally as possible for everybody, because everybody shares the cluster in the school. And the more you play games with it, it's just gonna shoot yourself in the foot. So that said, so obviously different projects have different data, different programs. They may even have different storage. So I just wanted to briefly mention that here. So Janet may have a 1 terabyte dedicated storage volume, and Daniel may have just the default 200 gigabyte quota. So whatever you do, just make sure that the files you're working on are on that, either in that dedicated volume or under the project directory that's underneath the faculty member's home directory. And that'll make sure that the files are within that quota, within that storage. Don't work in your own home directory because research assistants come and go, team members come and go. And if you have files all over the place, it's very difficult to pass them on or share them with the team going forward. So, and then obviously there's things like data agreements. You have to be cognizant of, like, what are the contractual obligations of your data, who you can share it with, who you cannot share it with. So just try to keep those in mind between your different projects. And I'll just give everybody a moment to look at this. So the funny here is that this is very painful and very true, right? So you got this. You're like, I'm done. I'm going to name this something short and concise and clear. And then it obviously goes through many, many revisions, many, many comments, many, many corrections, and then all kinds of permutations and different options are added. This is in a document. This can be handled by, revisions in the document. There are options in Word or whatnot to do that. But this is also true with code. This is very, very true with code because there are so many code files, and if something changes, it could break the whole setup, the whole pipeline, what have you. So the answer to that is code revision. And currently the best tool we think for code revision is Git. It's a command line tool. It's also built into text editors and file browsers so that you can see the changes as you or your team. This also enables working on code as a team to track your changes. It's like unlimited undo. So if something breaks, you can always go back to a point where you did a commit or a tag or a branch. These are some more. Depending on what you need, you can go further and further and more complicated with it. But let's just do a quick introduction to Git. So I'm here on my terminal and I'm logging into SSH bug at hpcc.wharton.upenn.edu. On Mac, you use the terminal. On Windows, you would use MOBA Xterm. And so we're logged in the HPCC. You see that the HPCC status command tells us that the cluster is about 77% busy right now. So I've already done this step. Basically what you do is you tell Git your name and your email address. And then say you have a directory of code. I'm just going to make a directory or some project. And I'm in my some project directory. And in here I have let's make a directory for notes. And then, in notes, I'm going to make a to-do file. So I'm going to stop right here and say that there are a couple different ways to create files and work with files. I like to use Vim at the command line because I work at the command line a lot, which is a really good programming editor. But you can use whatever you like, whatever you enjoy. That might be Emacs, that might be don't use Notepad if you're on Windows. You might use Sublime, you might use Visual Studio Code or the Atom editor. I've been recommending Microsoft Visual Studio Code to everybody because it works on all platforms and it has mostly everything you need right out of the box, and it makes a very nice environment for coding and programming. So I could use command line tools and say I can touch to do.text. I can echo lines to it. File lines to this file, or I can browse the network and I can get and access it that way. So I think I already covered this on another slide, but I'm just going to jump right into it. So in the Finder, it's WinK, and it's smb:/hpcc.wharton.upenn.edu/ your username. And I'm already connected there. And let's see, I just created this directory, some project. And I created a directory in there called notes. And there's a to-do.text. So I'm going to go ahead and open that. Let's see, open with. I'm just going to drag it into code here. So it says hello there. I echoed that. It's just that's the one-line text, one-line text file that says hello there. So I've got this project directory. I've got a notes directory in it. I want to make sure that all these files in here are tracked with Git. So I can cd to that directory. in my some project directory, and I can do a git init. And that creates a hidden dot file. Files that begin with a period, a dot, in Linux or on Mac are hidden. They don't automatically show. So if I do an ls here for list, all I see is the notes directory. If I do an ls-al all in a list, it shows me that there's some Finder crap and there's a .git file. And the .git file will contain the Git configuration and the revisions and the histories of the files. So you want to leave those alone. So let's get back to, let's see, I can go into my notes directory. And now that I've done a git init at my top directory of my project or my code directory, you don't necessarily want to keep everything in your project in Git. Maybe keeping giant data files in Git is not a good idea. Maybe you only want to do this on your code directory. So I've done it at the whole directory, but if you have code and big data all in the same directory, you maybe only want to do it on your code directory. So I'm just going to give you an example of, I don't know, let's say I'm going to add a line, say, you know, build a better electric car. That's my to-do. And I'm going to save my file. So now at the command line, I can see here, I can do a git status, and it's like, oh, there's this crappy DS store. But I can do a git add. You want to add the files you want to track. And always look at the status. So it says there's a new file, and there's these annoying files here, which I'll get to. And then let's say I make, and then I'm going to do a commit. So basically you do an add, a commit, an add, a commit. Every time you want to have, you have like a change or a revision of the file that you want to save. You could do that as fine-grained as you want. So we'll do a git commit, and we'll give it a comment, a message saying, so now we have a change saved. And we do git status. Oh, those stupid files. I'm going to add those. There's a special file that you can create that will ignore some files. So I'm going to ignore anything that starts with .ds or ._. So I'm going to create a file called git ignore. And I'm going to echo a line to it. I'm going to say ignore, use a single quote, ._* and ignore .ds*. Now if I do a git status, those annoying little files that the Finder leaves around are ignored. But we now also have a git ignore file. So I'm going to do a git add, git ignore, git commit. There we go. So we're on the master branch. Branches are a more advanced way of using Git. You can actually have your stable code. And if you want to work on a whole new feature or try something you think will break everything, you can branch the code, work on it, test that feature, and then if you don't like it, you can throw that branch away and still use your original master branch. Or if the branch works and you like it, you can merge it back into the master, and you've got a new feature, and you didn't risk breaking your working code. I will point you to, let's see here. I will point you to bitbucket.org. Bitbucket has free accounts for the university. You can sign up with your pen key. It's penkey at upenn.edu. You log in with your pen key password through and then this link here will take you to some great documentation. Bring that over here. On how to start from scratch with a new repository. And just like working in project directories, These repositories should probably be owned underneath of the primary investigator of the group so that they travel forward and not under an RA that may go away or a team member that may go away. So your primary investigator, your faculty member will want to create a new repository and then have you added as an editor of that project. And then you can do a git clone, which is a way of pulling it down from the Bitbucket website to a directory on your computer or in your home directory. So yeah, that way, one user can do the yellow edits, another user can do the purple edits, and they can all be merged into the same working code. So another thing to watch out for is if you're going to use Git other than just locally, if you're going to use it as a way of copying code to all around with multiple team members, don't keep the one you edit in the project directory. Keep the one you edit in your home directory or on your laptop. And when you make changes, push them up to the Bitbucket repository. And then before you run the job, go to that directory on HPCC and do a git pull to pull all the latest changes. So the copy of the code that's living in your project directory is just for running code, not editing code. When you edit it elsewhere, most likely on your laptop or your desktop, and then push the changes. Pull them onto the directory on HPCC at the command line, and then run your code. And that way, everybody on your team can have copies and edit. This is not so much a problem if you're the sole editor and you're just using git as an undo, but it's still something you want to consider doing. It's just good, basically good code hygiene, and allows you to instantly have all the benefits of Git if you bring somebody on and you want to share the code with somebody. Let's see here. So yeah, Bitbucket, log in with PenKey and have the faculty member add you.